welcome to our first keynote session of the day. It's my pleasure to welcome Dr. Donna O'Shea. She's the head of the Computer Science Department at Cork Institute of Technology. She's also a well-known figure within the Irish cybersecurity community, as she was a central figure in establishing the IDA funded national cybersecurity cluster called Cyber Ireland. So welcome, Donna, and thanks for taking the time to joining us today.
Thank you very much, and I'm delighted to participate as part of today's event. I guess what I'm going to start off with really is just a brief introduction to myself. As mentioned already, my name is Donna O'Shea, and my current position is actually Chair of Cybersecurity. I've moved on from my role as Head of Department, and I hold this professor position in Munster Technological University. The title of my presentation is actually all about future network security, and I think it's appropriate before I begin just to highlight my career to date in this area. So I did a master's and a PhD in the area of 4G networks and 4G systems, specifically in the area of service provisioning. I also spent some time working as a postdoc, and I worked in IBM as a software engineer, where I was particularly focused on software for network and service management across a number of different products, which include IBM Tivoli Net Service Quality Manager and IBM Tivoli NetCool Customer Experience Manager. I also worked in network and service management for SOA-based web service environments. But in 2013, I left my position in IBM and I returned to a lecturing position as an assistant lecturer in CIT, which is now called Munster Technological University. And I moved from assistant lecturer to head of department to my current position as professor of cybersecurity and chair of cybersecurity in Munster Technological University. And I was appointed this position under the Higher Education Authority Senior Academic Leadership Initiative, which many of you are familiar with, which aims to address, I suppose, the lack of leadership positions for females in the higher education sector in Ireland. So I'm very privileged and honoured to hold that position. I'm also a principal investigator in a national SFI research centre called Confirm, where I was strategically appointed and recruited for my cybersecurity expertise. And I'm also a funded investigator in another SFI research centre called Connect. And in essence, my expertise is in the area of network service management, security, but with a particular interest in 5G. That's where I like to operate most of my activities within. As mentioned already, I was a central figure in a national project called Cyber Ireland, and I think it's appropriate just to kind of give some context of the cybersecurity industry and the cybersecurity sector in Ireland. And I guess I just want to highlight some projects that I have key involvement in. The first is Cyber Ireland, where I was a part of the leadership team in establishing this cluster organisation, and I now sit on the board of Cyber Ireland. And I also lead another national project called Cyber Skills, and we're trying to develop the cybersecurity sector even further in Ireland by building up greater capacity and greater R&D collaborations. So I might just start off with an overview of Cyber Ireland. Excuse me now, there's an interruption here from a child.
Where's the car?
Are you okay?
Where's the car gone?
A child, sorry, my apologies. So basically, Cyber Ireland is an initiative that was basically required to establish the National Cybersecurity Cluster. So basically, Cyber Ireland is Ireland's national cybersecurity cluster. And this was actually originally funded by the IDA, and subsequently it's funded by Enterprise Ireland. And its whole purpose is really to provide a collective voice to represent the needs of the cybersecurity sector across the country. And it aims to do this by, first of all, building a community of cybersecurity academics, of industry representation, and of government services. And once it has a community built, it looks at how are we going to address the critical skill shortage of cybersecurity professionals. And then working and building upon that objective, it looks at how are we going to further develop the cybersecurity research in Ireland by developing collaborative R&D opportunities between companies. And CIT, or MTU now as what it was called, led the development of Cyber Ireland, but this is truly a national cybersecurity cluster. And we have now 110 cybersecurity industries participating in Cyber Ireland, where we're working together towards these very ambitious and well-defined goals. So I just want to highlight Cyber Ireland and its role within the Irish landscape. A key output of Cyber Ireland and a key goal of Cyber Ireland, as I already said, was to build a community. And a part of this community then was to build a solid pipeline of cybersecurity talent. And Ireland does have a critical shortage of cybersecurity professionals. And this is placing our digital economy at risk because we cannot secure ourselves against security threats, which we're all very familiar with at this stage. And Ireland's 2019 National Cybersecurity Strategy basically stressed the urgency of this skill shortage, the need for a national supply of talent and investment in research and innovation to ensure that our data centres in Ireland, which currently house 30% of all Europe's data, businesses and critical infrastructures are protected, and basically to establish the trust required for future inward investment. And most reports currently indicate that there is zero global unemployment in cybersecurity, and there is a reported 3.5 million unfilled jobs in cybersecurity. And the reality is the greatest demand for these cybersecurity jobs either exist in the US and Ireland. And that is primarily because a lot of multinational and American-based cybersecurity companies have based themselves in Ireland over the past number of years. And the skill shortages that exist in cybersecurity in Ireland exist not because of any progress or any attempts made by individual academic institutions in Ireland, but really it's the way that we actually design and deliver academic programs in cybersecurity. It was very siloed. So MTU offers a master's in cybersecurity, so does TU Dublin, so does UCD, and we all work independently and offer programs independently. But the goal of the project that I'm leading, called Cyber Skills, is to develop collaborations and partnerships with other universities. And the partnerships that we've developed include TU Dublin, UCD, University of Limerick, MTU, and we also have an international dimension with the inclusion of Virginia Tech and its Commonwealth Cyber Initiative. And by working together, we aim to address the critical skill shortages of cybersecurity professionals in Ireland. And we aim to do this in a very innovative, enterprise-focused, collaborative way. What we're doing is that we're actually using what's known as the NIST NICE framework. And through the 52 job roles that are identified in the NIST NICE framework, we're going to develop academic pathways aligned to those job roles, pathways that industry say they need. And we're going to reinforce that learning through a cyber range, which we've procured and instantiated. And this is the first cyber range that is available in Ireland for use for academic training and research purposes. And it's going to be very innovative in terms of, learners can actually take one module, they can take 3 modules, they can take 4 modules, they can build towards a major award. And we're also going to look at very unusual routes in terms of progression and articulation by looking at work-based learning and recognition of prior learning. And this, we have 3 pathways that are going to be offered in September. The first is secure network operations that we developed in collaboration with Dell. And we have 2 that we developed with MasterCard Ireland, which include secure software development and also secure architecture. So these are all well-defined job pathways defined in the NIST NICE framework. Now, why am I saying this? And I guess I'm saying it because I just want to give some context of what's going on nationally. This is a project that's been funded by the HEA. It's an 8.1 million project over a 4-year period, but also to recognize that cybersecurity is different. And if we want to do real research in Ireland in cybersecurity, we first of all have to to build up capacity, build up the cluster, and deal with the critical shortage of cybersecurity professionals, and build up, I suppose, and further building up then R&D collaborations. And we're at the going towards the R&D collaborations in Ireland at the moment, and building up some real capacity in research and innovation, and that's the goal going forward. So back to the topic for today's presentation, so I'm going to talk about 5G, and I'm going to talk about the requirements, the security challenges across 5G. Okay, that's what I'm going to talk about. But before I begin, I probably think it's necessary for me to explain what is meant by 5G. And I think the best way to understand 5G is to look at the various generations of mobile communications and the services that they have provided. So when I went to college, I had a mobile phone. It was called first generation, and all I could do was make phone calls. So first generation was all about voice. And second generation, we had phones that did voice and texting. So second generation was all about voice and texting. They were the services that they provided. And I'm sure many of you remember 3G and when it came out, and iPhones, and how it actually transformed the mobile communications industry. But basically 3G was voice, texting and data. That was it. And 4G was basically 3G but faster. And 5G is going to be faster again. And over the various generations of mobile communications, there has been what we call an evolution of security threats. In the first generation, wireless networks were targeted for illegal cloning and masquerading. That was the security threat that operators had to deal with. And in the second generation, message spamming became a problem. Basically people were able to broadcast unwanted marketing messages, and network operators had to deal with that security threat. In the third generation, we finally were being connected to an IP-based network. And so the mobile network operators were exposed to a whole host of internet security vulnerabilities that they never had to deal with before. And in the fourth generation, operators had to deal with the scale issue. Okay, so how do we actually connect huge numbers of IP devices and support now a broader range of multimedia services? And now we're moving into the fifth generation. And in the fifth generation, we have SDN, we have NFV, we have multi-tenancy, and we have cloud. And the reality is, it is no longer possible to secure our networks using the traditional perimeter-based approach to security, because the notion of a fixed perimeter actually no longer exists. Because in essence, we're no longer going to have dedicated hardware such as firewalls and routers. They're all going to be virtualized as network functions. But that is only just one part of the problem with perimeter-based security and approach to perimeter-based security. And I know there was another talk yesterday on zero trust, and I'm sure they discussed the technical challenges and the reasons and motivations behind zero trust. And 5G is a very important technology, because 5G is going to enable what we call a fully mobile and connected society, and it's going to support socioeconomic transformations such as productivity, sustainability and well-being. And it's going to support a broad range of use cases and models across a different range of vertical industries such as Industry 4.0 and smart healthcare. And as you can see here by this diagram here, they're typically referred to as these type of services. The first is an enhanced mobile broadband. And then we have the ultra reliable low latency communication services and massive machine type communications. And these are typically the services that are provided in 5G. An enhanced mobile broadband will enable applications such as 3D video, work and play in the cloud, whereas ultra reliable low latency communications have very strict latency requirements. And as a result, self-driving cars or autonomous vehicles and industrial automation applications fall within the URLLC category, or ultra reliable low latency communications category. So this unique combination of high-speed connectivity, ultra-reliable, very low latency, and ubiquitous coverage is basically there to support applications such as smart vehicles and connected cars. And in this environment, a split-second delay is going to mean the difference between a smooth flow of traffic or a major traffic accident. And that's the reality of the environment that we live in, and the reason why security is such a significant and important challenge within 5G. And before we continue, I think it is important to reflect on the significance and importance of security in 5G, and obviously the significance and importance of security across all the domains. But the advancements that I covered in the previous slide with 5G will be at risk unless we can secure this strategically important communications infrastructure. And 5G introduces new security risks for network operators, because first of all, we have an increased threat surface with many more entry points as a result of Industry 4.0 and Internet of Things. And certain pieces of networking equipment are also going to be more vulnerable and more sensitive to threats such as confidentiality, integrity, and availability. And these are going to become major security concerns. And 5G is also going to extend relationship models, okay? Because we're going to have new relationships between people and devices, and we're going to have new relationships that will form part of automated business processes. And these relationship models make the environment that we work in, again, more complicated and difficult to secure. And the landscape of 5G security is actually further complicated by an increasing diversity of threat actors who are becoming more sophisticated and be professionalized in their activities. And we know this. We only know it, I think, and it has come to light really recently in Ireland, but we've been talking about this, people who have been working in cybersecurity for a long time now, and I've been harping on about this for a long time now. But you know, we have well-resourced criminal gangs, and they work in partnership with nation states, and there are exploit kits being developed that are developed by cyber criminals that are basically reduce the technical barrier to entry into cybercrime. And you know, they minimize the knowledge required to actually perpetrate cyber attacks, which has led to a rise in volume of attacks. And this is the reality of the environment we face in, and this is the reality of you know, the complex threat landscape. And you know, we need to start thinking outside the box and how we're actually going to address the technological requirements and the security measures to protect our networks and our infrastructure and our critical infrastructure protection. So this is why I'm talking about this, because it's just so important. Okay, so we're moving on to 5G network security, and I'm sure at this stage now you should have a clear understanding what 5G is, why it's important, and why security in 5G is important. You know, when preparing for this keynote, and if you're interested in 5G security, there are some key publications that would be remiss of me not to mention, and they include key standard from 3GPP and key publications from our NGMN Alliance, and some key publications from IEEE. And I just want to briefly highlight these, because if you really want to get into the nuts and bolts of 5G security, you should read these, what I find excellent publications. Okay, so the first two are from 3GPP, TS33401 and TS33501. And these are mainly the security architecture 5G for 5G, both in the RAN and core and new radio. Okay, and it gives a very comprehensive, but it's a very general specification on security requirements, and it looks at, you know, authentication procedures, security procedures, keys and integrity and trust domains. Okay, so that's what it looks at. It's more of a security architecture. The Next Generation Mobile Alliance has a really good paper, and that's the name of the paper there, the third row, and it provides security recommendations basically for network operators to improve their access network, to prevent, I suppose, or mitigate against denial of service attacks. And there's some really good papers out there that use the Next Generation Mobile Alliance paper as well, and have some kind of cool diagrams on it. But you know, in each classification, this paper identified key issues such as flash network traffic, radio keys, user plane integrity, subscriber device level security, mobile-to-mobile IoT devices, triggering network overlay mechanisms, and configuration issues causing denial of service. And these are all real, you know, threat vectors in 5G. And it is, as I said, this is a really good paper and it's very accessible, and I'd certainly advise people to read it. And this is another very accessible paper from 5G PPP, and it provides a phase 1 security landscape document, and it's very accessible. You don't need to be a real tech head to read this, but it highlights 5G security risks, requirements, architecture, access control, privacy, trust models, security monitoring, management, all that kind of fancy stuff. And finally, there's a survey paper, and it does what it says in the 10 from Kay et al, and I'd recommend other people to read that as well. So there are all the sources of information that I used to talk about this slide. And 5G has a number of security pillars. And security in 5G is basically what we refer to as a multi-dimensional subject. And the diversity of devices and services in 5G make it more complex. And when we talk about 5G, we talk about the entire ecosystem, including IoT devices, Industry 4.0, cloud, internet services, digitalization, and supporting technology. And this diagram here kind of highlights some of these dimensions, which, as you can see, include RAN security, SDN controller security. There's a whole section on predictive and proactive security analytics. Because you're suddenly using NFV, you know, you have hypervisor security. Because you're doing network slicing, suddenly you need to talk about orchestration security. You also have security function virtualization for your secure secure function chains. Then you also have network slice security and security at the edge. So you can see there are a huge number of dimensions that we actually need to consider when talking about 5G security. And a key underpinning aspect of each of these identified pillars is that they're nearly all emerging. And if you look at the black and the red there in that diagram, they're nearly all emerging as a result of virtualization and cloud technology being integrated into our mobile networks. And with technology such as SDN, it's now possible to flexibly configure routing paths between dynamically configured virtualized network functions. And it's also possible to support multi-tenancy and slicing on virtual networks on a single substrate, allowing the creation of mobile virtual network operators. And with these opportunities, of course, there comes challenges. And I'm going to discuss some of these challenges today. I'm going to first of all discuss a network slice security, and then I'm going to just briefly go into network function virtualization security and SDN security, because in order to implement network slicing, the two underpinning technologies to actually do that include NFV and SDN. Okay, so we're going to look at security across each of these dimensions. So we'll just move on to the next slide. So network slicing. In the same way that the 3GPP and the Next Generation Mobile Allowance has issued architecture and really good papers on, you know, 5G security considerations, so too have 3GPP, and so too have they done this for network slicing. And these are the key publications if you're interested in digging down deeper into network slice security. And we're talking here now about TS33811, TR33813, and across these two 3GPP specifications, we're looking at some key security challenges and solutions in network slicing, and TR33813 looks at slice security, inter-slice security, and roaming issues. The Next Generation Mobile Allowance also identified 10 further security issues, but this overlaps in part with this specification TR33813. So if you're going to read this, then you should read the Next Generation Mobile Allowance publication, because they actually go together. Then we have the 2 ITSE publications, where it looks specifically at network function virtualization, and it provides an overview of network slicing and use cases, and how to actually look at network slice creation, network slice subnet creation, and all the different entities within the core mobile network that you need to actually implement this. And then the next one also looks at security monitoring, providing gap analysis for NFV security, etc. And then there are some papers here as well that people should consider if they want to go deeper into network slice security. And these were the papers and the specifications and the white papers that I have used in preparation for today's keynote. Okay, so network slicing. For those who don't come from a telco background, I suppose I should explain first of all what network slicing is. And network slicing is a term that's used to describe the creation of several logical networks sliced from a single physical substrate that is customized to meet the divergent requirements to support the use case and business models of 5G. And I just want to highlight that there are 2 types of network slicing. So the first type of network slicing that I want to talk about is what we call vertical network slicing. And what you're going to see in the future is that there are going to be private 5G networks, and even say in the SFI Research Centre Confirm, it has its own private 5G network infrastructure as part of its testbed facility located in University of Limerick. And this is owned by University of Limerick and the Confirm Research Centre. Okay, it's not owned by Vodafone or anybody else. And of course, on a factory floor, you may want to slice your network to meet the requirements of the applications or services that are running on the factory floor, such as industrial automation or extended reality applications. And so if you want to slice your private network within your factory floor, then that's typically called vertical slicing. And horizontal slicing is, when you actually need to go across your mobile edge compute to your cloud to your wide area network. That's a horizontal slice. It's a more end-to-end slice across mobile network operators network or spanning multiple operator networks. And that's the difference between the 2 of them. The picture here is to represent the complex association or the complexities in network slicing. The dots represent virtual network functions, and the lines represent the links or the communication between these virtual network functions in order to allow them to communicate. And the box surrounding the dots and the lines is basically what we call a slice. And you can see here the green mobile virtual network operator basically requires 3 VNFs, and in order to instantiate that network, it basically creates an overlay of this physical infrastructure here in the bottom in the circle, and basically spins up virtual network functions and uses SDN to enable communication paths between them. And that green box there is basically a logical network that sits upon this physical one here. But the blue network also sits on this physical network, and so does the purple one. So, but a network slice can be located within a single administrative domain within a network operator, or can span across multiple network operators' administrative domains. And this again adds to the complexity associated with network slicing, because now you're not just dealing with security protocols and procedures in a single operator or administrative domain, you also need to consider them moving between domains. And that diagram is, I think, a very good representation of how network slicing works in reality. So, okay. So what the purpose of this slide is really to go through the security lifecycle associated with network slicing. And this is actually taken from a paper here, and I definitely recommend you to read it, 5G Network Slicing, a Security Overview in IEEE Access. And and it comes as well from a 3GP document that talks about inter-slice security, so it's kind of based on that as well. But there are multiple phases when you're actually creating a network slice. So, you know, you need to prepare your network slice, you're going to commission your network slice, then your network slice is actually in operation, and then finally you're going to decommission your network slice. And across these different life cycle stages, there are particular security challenges that can emerge. And the first phase is basically all got to do with the preparation of the network environment, where you're going to design or create or modify the network slice templates. Because if you're actually going to create a network slice, you first of all have a network slice template, and you basically create an instance of that template to implement your network slice. And your network slice template is basically a description of the components, the structures, and configuration of a slice. And the main point of attack in this phase is actually in the network slice template itself, because a poorly designed network slice template can mean that it can be very easily tampered with or improperly implemented in the underlying network infrastructure. There are a few specifications and examples out there in network slice templates. I don't know them off the top of my head, but I have used them in different projects and specifications if anybody wants more information on how to get a good network slice template. So then the next thing what happens is that you have to commission and instantiate and activate your network slice, and this is all located here in this second box. And within this box, you know, and I guess the main problem within this phase is that you know, you could have a fake slice, or you could have a change of the configuration of a slice. And the natural point of actually attack within this phase is the APIs themselves, which would allow an adversary to interfere in the installation or the configuration or the activation of a slice. And then we have the runtime of the slice. So this is when it's actually being used. So when it can be subject to modifications, you know, when, you know, upgrades or changing configuration or associations and dissociations. And in this part of the phase, the biggest threat that is for network operators is actually denial of service attacks or performance attacks or data exposure attacks or privacy breaches, and that's really the problem in that phase. And finally, we have the decommissioning phase, which is the last phase of the life cycle. And within this, the resources and network functions are now freed, and the slice doesn't exist anymore. But the main threat during this phase is that slices may expose sensitive data that are being improperly handled during the commissioning. Okay, so there are the main security threats and challenges that exist within network slicing, and in particular when you're actually creating, running, executing, and decommissioning a network slice. And they're all supported by well-defined 3GPP and next generation mobile networks and various journal papers, and I've just kind of gone through an overview of them. Network slicing relies on, as I said already, two underpinning technologies, NFV and SDN. And I'm briefly going to go through the security challenges in NFV and SDN, because ultimately your network slicing will depend on the robustness of the security of these underlying technologies. And that's why I'm actually covering it very briefly. So before I begin, I'm going to explain what NFV is. And NFV is basically a replacement of network functions that were typically deployed on monolithic dedicated appliances such as routers and load balancers and firewalls. And instead now we're going to move these to virtualized instances, and we're going to run them on commercialized off-the-shelf hardware, typically managed by a Kubernetes instance or something like that. And with common off-the-shelf hardware, we don't need any proprietary hardware. We just have Linux or OpenStack. And basically firewalls and routers, etc., become essentially software functions. And that brings a whole host of other challenges in terms of security, which I'm not going to go into at the moment. But in terms of advantages, NFV basically allows network services to run in software using off-the-shelf hardware. It offers greater flexibility, reduced cost of deployment, and it allows network functions to be added, removed, modified, and scaled in response to changing users and security requirements. And the composition of network services is typically referred to as a service function chain, and that's why I have tried to provide it down here. So you could have, you know, a service function chain by saying, look, I have a virtual network function that's a firewall, and once it goes out of the firewall, I want it to go into a deep packet inspection, and then I want it to be encrypted, and then I want it to do data monitoring and decrypting. And that's basically an example of what we call a service function chain. And a service function chain is actually supported and enabled by SDN advanced traffic steering techniques and network programmability features such as dynamic management of VNF virtual connections and an underlying data plane. So in order to create a service function chain, it's not just VNFs, you need to be able to dynamically reconfigure your underlying infrastructure to support the execution of that chain. And that's why NFV and SDN work together. And this diagram here is an example of an SDN core network, and I'm not going to go into examples or go into the function of each core network element because we'll be here all day. But what I'm trying to emphasize now is that mobile operators are moving to common off-the-shelf hardware, and they have implemented on top of that some software-defined infrastructure controller or hypervisor solution. So they're basically able to spin up virtual machines and containers managed by large-scale distributed system such as Kubernetes or whatever, okay? And in a 5G network, the VNFs that you need will include your home subscriber service, your DNS server, your proxy call state control function, your PCF, your gateways, and etc. And in order to get communication between these VNFs, you need your SDN network, your data plane to support that. And the way things are going at the moment, we're talking about next generation SDN, and I'm not covering next generation SDN as part of today's slide deck because we're going into P4 and data programmability and data plane programmability, but it doesn't matter. You have SDN, and you know, you're able to reconfigure your underlying data plane or network infrastructure to support your service function chains that work underneath it. And up here in your network infrastructure, this is where your network slice templates come in, and the various functions actually instantiate that template into VNFs and network slices. So now that we have talked about NFV, I'm just going to go through some security challenges in NFV. And we have a whole range of security challenges, and if you want to look at them here, you can just look up the IEEE Communications Magazine by Shankar and Al's paper there, and certainly that will give you a very comprehensive overview. But the main NFV security challenges include hypervisor vulnerability, open source vulnerability, software unreliability, virtual monitoring, secure boot, user tenant authentication, performance isolation, attack detection, etc. Okay. And I have an example actually provided here by this paper, which I thought actually explained it quite well. So in this picture here, it depicts like basically one practical scenario of what is referred to as a DNS amplification attack. And in this attack, basically you have a network function infrastructure that hosts a virtual DNS server instance. And basically what the attacker does is that it starts sending loads of DNS queries to your network. And your virtual DNS server quickly becomes overloaded. And in response to that, because your network now can basically scale with virtual network functions in response to service and user demands, it basically spins up another DNS to be able to deal with the volume of the queries. And again, the attacker kind of realizes, okay, look, I'm going to keep sending messages. And in response to that, your infrastructure keeps spinning up virtual DNS servers to resolve the spoofed IP addresses. And ultimately, this will actually cause a recursive DNS servers to, to deal with these amplified DNS query responses. And ultimately, this is going to result in service disruption and unavailability because of resource exhaustion. And this is very similar attack to the Mariah attack, which I'm sure many of you are familiar with, because in the Mariah attack, which was the largest Internet of Things type attack, it used another, you know, I suppose, technique, which was known as a DNS water torture technique, by basically sending unresolvable domain names to the authoritative DNS server of target web hosting organizations. And again, the attack became effective when the DNS server became overloaded and couldn't resolve the names, and so it redirected to another DNS server, and this basically caused the attack to be propagated across an entire infrastructure on behalf of the bot. And this is an attack that lasted 77 hours, powered by 24,000 IoT devices, which really represented only a fraction of the infected IoT devices within that bot. And it left much of the internet in the East Coast in America very much disrupted, and it was also reported to smash Liberia off the internet. So this type of DNS amplification attack or resource exhaustion attack is not outside the realm of possibilities, and that's why I provided it as an example today, because it's very, very familiar to the Mariah attack. So SDN. So as I said, SDN is equally important to NFV, and I'm going to briefly talk about the main security challenges in SDN, and these include. And maybe before I go on about security challenges, I just want to explain maybe to the audience what SDN and why SDN is important. And SDN emerged as a problem to deal with configuring VLANs. And network managers needed to make sure that a VLAN, which is used by a virtual machine, is assigned to the same switch port as the physical server actually running that virtual machine. But with the virtual machine now being movable, it's necessary to configure the VLAN every time that virtual server is basically moved. And the requirement for SDN basically emerged to deal with the flexibility associated with server virtualization, and the manager now needed to be able to dynamically add and drop and change network resources, and they needed to be able to do this in a flexible and programmable way. And it couldn't do that with traditional network switches, because the control logic was basically co-located with the switching logic. And as a result, SDN emerged, which basically separated the control plane logic from the data plane functions. And this allows for a far greater degree of abstraction, enabling the network to be treated as a logical entity. Okay, so that's basically the importance of SDN. Now, within SDN, what I'm talking about here in terms of security challenges include access control. So within SDN, there's what we call a northbound interface, which is up here, the controller, and then we have the southbound and down at the bottom. And typically security challenges are divided into these categories. So you can see up here, first of all, we have something talking about authentication spoofing, denial of service, system variable manipulation, elevation of attack and API abuse. And then because your application sits on your northbound application, you can also have eavesdropping and man-in-the-middle attacks. And then within the controller plane, you would have typically saturation attacks, fingerprinting attacks, SDN rootkits, and topology poisoning, host location hijacking, and link fabrication attacks. And they're the most common attacks within the controller plane of your SDN network. And finally, in the southbound layer, you would have, or your data plane layer, you would have information disclosure, flow entry flooding, firmware abuse, and control message manipulation. But across all these different layers, the main types of security challenges relate to access control at north, south, east, westbound, communication security. So, you know, OpenFlow by default doesn't actually specify the use of TLS, which is a bit of a problem. You know, or you could attack the controller performance through some type of denial of service attack, or you could look at control plane fault tolerance. And by this, you're going to have multiple SDN controllers across a distributed network. And how do you actually poison, I suppose, the network operating system across a cluster of SDN controllers? You could have a network topology poisoning attack, where again you're trying to attack the network operating system of an SDN controller. You could look at policies. You know, how do we actually violate policies that are implemented in the data plane, you know, and how do you actually verify that a policy actually is appropriately implemented in the data plane as well? And these are all major security issues. And these are all very well investigated as specific security challenges in SDN type networks. Okay, so I'm nearly finished. This is more or less my last slide. And what I want to say here is 5G is not an incremental advancement over 4G, okay? So what that means is that security principles need to be redesigned according to the new design principles and architectural requirements of 5G. And the reality is that in 5G, you're going to have very diverse technologies, we're going to have new security vulnerabilities, and we need to look at security of design, and this is essential. And this involves security, including security design phase, water and bolt-on nature, and anybody that in security knows that this is a requirement. And diversity also requires a system to adjust and adapt. And in order to achieve this, you know, we need to look at how we can manage this through policy-based yet centralized network control. And as part of this vision, AI and automation is going to play a huge role. And the development of algorithms that basically leverage a centralized view of network state, basically to reconfigure the network based on the unique security requirements of the user and the applications and of the services. And this is the next generation's vision for a 5G security system. And being honest, it's one that I agree with. You know, supreme built-in security, flexible security mechanisms, and automation. They're the three pillars that I believe are required for future network security. And that brings me the end of my presentation, and I'll open up for Q&A. And that's my email address as well, in case anybody would like to talk to me afterwards. Thank you.
Thank you very much, Donna. It was a very interesting presentation. We have a few questions in the Q&A already, so I'll start from the first one. There's recently been reported in the Irish press that Ireland's NCSC has been unable to recruit a director for over a year, and that is due to the salary offered because of, and it's due to the salary offered being inadequate. What are your views on this? Is the narrative about inadequate salary and associated status a fair representation of the problem, or are there other factors involved? And if so, what are these? That's a eventually controversial one.
Yes, yeah, I guess as part of Cyber Ireland, we were recently asked to participate in an Oireachtas committee discussing the HSE attack on our HSE and health system. As part of that Oireachtas committee meeting, this actually came up, and you know, what was discussed as part of it was, you know, they brought in recruitment agencies and, you know, discussed the salaries of the CIO, and they compared that to the salary of our NCSC director. It's not really for me to comment on salaries of, you know, I'm more of a technical person, but, you know, what is clear is that there is a discrepancy between market rates for chief information officers in industry and chief information officer of our critical infrastructure, you know, in the state of Ireland. And I think that needs to be addressed. And I believe it will be addressed. That's my personal view, and it's not a political one, you know, or anything like that. And again, it's not for me to discuss salary ranges, and that wouldn't be my area of expertise. It's just, you know, it's just a discrepancy, and if they're serious about cybersecurity, they're going to have to address it.
Yeah, absolutely. Another question here from Tim. Given that virtualization depends upon dynamic parsing of configuration metadata, and that the root cause of many historic security problems have been vulnerabilities, interpreted languages, and parsers, has any 5G security research being focused on identification and formal security assurance of all architectural components that perform parsing interpretation functions?
I haven't come across that in any of the literature of parsing or interpretation functions, but that doesn't mean it doesn't exist. You know, I think that this will probably go back to P4, because P4 is basically next generation SDN, and suddenly now we are going to have a programming language that is going to basically define, you know, the security operations in your data plane. And that's like a programming language, like any other programming language. So, you know, it may it may exist there. I would think that that's probably where it's going to be most relevant, you know, within the context of 5G, if people are going to start using P4 and next generation and stratum switches and stuff like that. And that is probably, you know, what I believe, but that's as far as I would know about that. So I hope that addresses partially your question.
All right, thanks. Then another question, such an interesting talk, Dr. O'Shea, thank you. My question concerns the security of machine learning models deployed on edge devices. What do you determine to be the biggest risks and challenges associated with machine learning deployments? Thanks.
Yeah, I mean, adversarial machine learning is becoming a hot topic at the moment. And it's something that we all need to start considering, because if a model is being slowly infiltrated by an attacker, especially during the training phase, then obviously the decisions in which that machine learning model is built on will be, you know, will be implemented on the floor. And that may be fine in certain contexts and it won't have a big issue. But if in the area of smart manufacturing or the pharmaceutical industry that's leveraging machine learning models, you know, even just a very, very small you know, change in the operation of a machine learning model could actually impact the quality of the drug being produced, which may impact lives. And again, it depends on the use case and application. I think that there are a lot of solutions to this, you know. So there are this federated machine learning models, you know, where they don't actually share the models, they just share the data between them. And again, this isn't really my area of expertise. Mine is very much in network and service management, and I would use machine learning just as a tool instead of doing deep research in it. But certainly there's been a lot of research in this area, but there's an awful lot more to do in order to secure machine learning models. I think what's also very interesting within the area of machine learning is explainable AI. And I have a research project that's operational with McKesson as actually the industry partner in this, and we're looking at it from a smart healthcare perspective. And what in explainable AI, what we're looking at is, okay, look, your machine learning model has made a decision. How do we actually understand why it made a decision or the logic behind that decision? And if you think about that in even a network operator's perspective, you know, you may have a machine learning model that says, right, I'm going to spin up a new virtual network machine, or I'm going to, you know, tear down this VNF, or I'm going to make some type of decision about my network. But as a network operator, you don't know why it made that decision, you know. So how are you reassured that the network machine learning model is actually operating efficiently and effectively and the way that you design? So I think that the whole attack on machine learning models and explainable AI is going to become more dependent on each other as kind of verification and kind of closed loop, you know, systems. So I think for me, they're related, yet they're not related specifically in the literature, I don't think, at the moment.
Yeah, all right, that's great. Then we have another question from Cyril. It says, thank you, Donna. Excellent topic and excellent presentation. How would SDN support microsegmentation for a ZTN architecture? And the second question, which is related to the previous point, is could ZTN support and address security concerns in 5G? What are your thoughts? Okay,
so I guess maybe for those who don't know what a zero trust network, I presume you're talking about zero trust there, Cyril, and our zero trust network. So the traditional approach to security is we have a perimeter-based approach to security. Okay, so you have a firewall, and you know your firewall protects your network. It's basically a castle. And inside, once you're inside your network, you do try to implement a range of security measures using defense in depth techniques, which include microsegmentation. Okay, or include segmentation techniques implemented typically by SDN. With zero trust, there are typically zero trust is basically flipping the whole architecture of security on its head, and it says that instead of having security in the perimeter, and instead of trusting entities and elements and people inside the network and trying to implement defense in depth techniques, Instead, we're going to assume that no one is trusted, and we're going to authenticate and encrypt every single piece of traffic information. There are no frameworks for implementing zero trust at the moment. So it's, this is going to take some time to adopt a philosophy of zero trust and implement zero trust in realistic and in realistic networks, okay, in actual large scale deployments. But according to NIST, there are a number of different ways that you can implement zero trust, one of them being microsegmentation, and the other being software-defined perimeters. And I'm actively looking at implementing and evaluating security in using software-defined perimeters in multi-cloud environments. So it's an area of research that I'm very actively investigating at the moment, and hope to have some papers emerging from it soon from various master's and PhD students. So yes, SDN is going to be a way to implement microsegmentation as part of a zero trust network, and that's going to be the reality. But it's going to need more. It's going to also, I suppose, that's just one way of doing it. You could look at software-defined perimeters and looking at that architecture as well. But then if you're looking at an alternative architecture, then there's a whole host of security challenges that emerge as a result of that implementation as well. And none of the questions related to that have been fully addressed yet.
All right, that's great. So I don't see any other question in the Q&A at the moment, and we're also running towards the end of the session. So I would like to thank you again for taking the time for joining us today. It was great, and lots of food for thought in your presentation. And then I would like also to thank our attendees. And just as a quick reminder, if you would like to keep discussing some of these interesting topics, there is a forum on the member area of the website.